Hello everyone, this is a recap of our Preceptorship with Dr. Orr by Taylor Kaiser and Jacob McDermott. A little bit of background on our preceptor. Dr. Matthew Orr is an ophthalmologist here at Ohio State who practices at the Eye and Ear Institute. He specializes in vitro retinal surgery and corneal anterior segment diseases of the eye. His research interests include imaging techniques, integration of artificial intelligence to aid in screening of eye disease, and drug delivery systems. Jacob and I gained two valuable experiences through this preceptorship. We were given the opportunity to observe the Swindle-Riley lab for biomimetic polymeric biomaterials. Additionally, we not only observed Dr. Orr's clinic at Ohio State's Eye and Ear Institute, but worked with the photography team on a project that will be discussed later. To dive into our first experience, Dr. Orr introduced us to his colleague, Dr. Riley, who runs a lab for biomimetic polymeric biomaterials. She showed us around her lab located in Fontana and the many projects she is working on. Specifically, she is working on a project with Dr. Orr, and they are creating a biomimetic injectable hydrogel vitreous substitute, which is a bilayered capsule for the delivery of bevacizumab to treat macular degeneration. This would save the patient from receiving multiple injections in the eye every month. Their work so far has shown great success, and they have actually begun work with the company to consider the logistics of creating the device. We hope to see this on the market in the near future. This was a really cool opportunity to see the intersection of engineering and medicine at work. Moving on to our clinical experience. We had the opportunity to observe the daily flow of clinic in the space at the Eye and Ear Institute. We met with various key players in different groups within the ophthalmology department who make the clinic run. As illustrated on the screen, such teams include the medical photography team, the research team, and several clinicians. Besides the patient visits, something that is often missed is what goes on behind the closed doors within the clinic, where all the magic happens. Thus, it was interesting to see how engineering intersects with Dr. Orr's clinic specifically, and the importance of a team-based approach. It was evident that this field relies heavily on advancements in medical technology to provide the best diagnostic and treatment plans for patients. As a biomedical engineer, this is very encouraging and offers the ability to change the lives of many individuals. One of the teams we had the privilege to work with was the medical photography team. We were introduced and interacted with the various imaging modalities utilized in clinic, including an eye ultrasound, optical coherence tomography, or OCT, confocal scanning laser ophthalmoscopy, a CSLO, and scanning laser polarimetry, an SLP. We even had the opportunity to observe patients receiving different images of their eye. Additionally, we observed the behind-the-scenes work where the photography team views the images that were taken for each patient. Of particular interest was the OCT machine used to image your retina, which an example of the resulting pictures are illustrated on the screen. This graphic illustrates the process the medical team encounters to acquire and send the appropriate images to the clinician. Thus, the photography team retrieves images of the eye from different planes of view using the various machines and imaging modalities previously discussed. Once the images are retrieved, they review the images to be sent to the clinician for potential diagnosis, which is the final step. While the imaging devices themselves are rather complicated, there are various areas of improvement. While reviewing this process in action, Jacob and I realized the lengthy and rather time-consuming process they go through to review the images manually.
This leads us to our potential innovation. We attempted to come up with a script that could identify, with a relatively high accuracy, if the OCT retina image showed a tumor. Since the photography team looks at these images and still has to send them to doctors for diagnosis if they believe them to be tumorous, this could save the photography team a lot of time by auto-sending certain images to the doctors. This would allow the photography team to focus on other tasks that may require their expertise more. Looking at our script, you can see we have our script and a few images we're going to go through to show how this works. So first we'll run, you need a standard and then the image you're testing, or what the inputs are for this. So you run the standard with one that we know has a tumor. So then we kind of see what the script does as it goes through. The images open up. So it takes the initial images, does this for both that you input. Takes the initial image, which is of course red, green, blue, so it has 3 different layers of intensities of the matrix. It takes out the red image, separates that, it amplifies that because as you can see on the clean, healthy one, that basically just turns it red, whereas on the one with the tumor, that amplifies the tumor, it makes it a lot clearer. Then it converts that, and it identifies where it's not bright red, and identifies those as black. As you can see, this one's pretty clean. This one is not. And then it compares the difference in the amount of black of these two images and outputs for this one, because that image the difference was big enough, outputs this patient may have a tumor in the OCT scan to be sent to Dr. Orr, as that would be the next step. But then running it against a healthy one. Again, you see it goes through the same steps. Right, it goes all the way through, takes the red image, amplifies it, converts that to black and white. But you see on the healthy one, while it is not a totally perfect circle like the standard, that difference was not enough to warrant there being a tumor. So it does not appear this patient has a tumor, but please review, obviously, computers are imperfect, so these would probably still go through some form of verification by the photography team. As the semester and our work on this comes to a close, these are some of the issues we would try to alleviate with our next steps. The circular shape of the eye made this rather difficult. Because the image is being converted into matrix values, which are square compared to the circular shape of the eye, there was no good way to remove the background from behind the image. Comparing the patient image to a standard should help alleviate this, but a more refined technique would still be needed. Additionally, the difference between the patient and the standard images that was determined to be significant enough to identify a tumor was relatively arbitrary for our purposes. A more standard value could be determined through testing of various images with various technicians and/or clinicians. The images also need to be oriented properly to minimize that background so the amount of black in an image is not exaggerated. While each team could set a standard orientation pretty easily, that may not be consistent across clinics, which could lead to some issues for the patients. In conclusion, we saw and experienced a lot through this preceptorship. We saw various novel concepts being worked on in the research lab and many applications of various technologies in the clinic. Working alongside some of the engineers gave a lot of insight into the way these professionals operate, and we enjoyed it a lot. Thank you.